we're talking about decreasing the buffer in order to get closer and closer to real time. But by decreasing that buffer, you're introducing the risk of rebuffers. And rebuffers are probably the most annoying thing when you're watching a video.
There is always a sacrifice of stability with latency.
Even as we reliably start decreasing latency, all throughout the chain from end to end, from broadcaster out to delivery, every issue you can have along the way gets magnified when your margin for error is down to milliseconds instead of potentially seconds.
I'm Matt, the organizer of the SF Video Technology Meetup and the Demuxed Conference.
And I'm Steve, creator of Video.js, the open source video player.
And I'm Phil, streaming specialist at Mux in London and organizer of the London Video Technology Meetup.
And you're listening to Demuxed, a podcast for and by engineers working with video.
Demuxed is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com.
We're always looking for topics, so if you have any suggestions or just want to tell us how wrong we are, you can find us on Twitter at Demuxed.
Hey everybody, welcome to the Demuxed podcast. This is our first attempt at recording during quarantine. So all of us are at our respective home, social distancing. Today we wanted to try something new. You might have noticed that we didn't introduce a guest. That's because we didn't have one today. We had been talking a lot about this low latency stuff going on with Apple's announcements, and it's kind of a really hot topic right now with everybody trying to start new work from home distributed apps and things. So low latency real-time video has all kind of come to the forefront again, and that's dovetailed with Apple's recent announcements, which we'll dig into in a second. But we were like, we can just talk about this. So we're going to do a two-parter. Phil and Steve in particular have spent a lot of time thinking about this as a topic and writing about it. You might have read a blog post on the Mux blog or seen Steve talk about it in the last year or so. So we figured we'd just dig in. This first episode is going to be more along the history of low latency, real-time video, what that ecosystem looks like, make some definitions, and then talk about kind of Apple's announcements up to this point and where we are. So that being said, we're going to kick this off. So Steve, since you've kind of done a few of these talks, actually, and Phil, you've both defined this. Why don't y'all define low latency?
So yeah, I'm just kind of I'm hesitant to jump too deep into it just because it seems like, maybe people don't know exactly what we're talking about. So kind of stepping back to I think maybe the applications that are using low latency might help kind of frame the conversation here. And I kind of see the main use case for this concept of low latency live streaming being interactive live streaming at scale specifically. Right, so let me talk about that in specifics here. So you have this idea of real-time chat, right? So Zoom, Google Hangouts, that's already real-time interactive audio and video. You can talk back and forth to each other in real time. There's not weird latency that feels like you're on a long distance phone call and you have to pause and wait for people. That's what we mean by latency, right? Is that the time between something happens in real life to when it shows up on the other person's screen.
Yeah, and in video, we tend to call that glass-to-glass latency. The glass of a camera lens to the glass of a device.
Yeah. So you have this idea of real-time chat, and then you have, on the other side, you have say broadcast live streaming. So think the Super Bowl, you're streaming to millions of people. Typically, the Super Bowl will already have baked into it. At least I heard that it had as much as 30 seconds of latency already baked into it so that they could respond to issues that happen in the stream quickly, or even just weird things that happen, a newscaster flubs something or cusses or something, and they have to go back and bleep it out. It's already latency built in. So you're not really talking about low latency in that type of scenario, the big live streaming event scenarios. What we're talking about is kind of landing right in between, and we're thinking about applications like Twitch, where you're watching your favorite gamer live stream their video game, and you're chatting alongside, and the gamer is maybe responding to your chat in real time. or games like HQ Trivia, the phone app where they'll have a live host answering questions or giving you questions to answer, and you want that like responsiveness to feel interactive. So it's not real time, it's not real time chat. It's somewhere in between where you have a large audience, not all interacting with each other, just interacting with a host, but you have that like real time feedback happening.
Yeah.
What I think is interesting there is really the differentiation between this interactivity that is a few seconds and this interactivity that's immediate, this real time communication as it's called, and that really feeds into the technologies that people think about and select when they're trying to solve these business cases, because you don't need a real-time technology for 5 seconds of latency, but you do need a real-time technology for, sub-second latency. That tends to be where people start to think about drawing a line. Around, sub-second is infeasible with more traditional technology approaches, and is why we have things like WebRTC on the internet, which we'll get onto in depth, I'm sure, in a minute. But this tends to be where the line is drawn, somewhere between 500 milliseconds and a second is a real-time experience versus kind of this low or ultra-low latency concept.
Yeah, the way I've started describing this to people that are like programmers and familiar with the concepts of the internet, the huge difference is how much of your normal like web application stack you can use for one versus the other, and how much of a difference that makes for both cost, who you can hire to help work on it, like all those kinds of things. Like HLS and these streaming protocols over HTTP, they all use your normal CDN. They're all your same like CDN contracts. You scale it in the same way that you would scale, or a very similar way that you would scale like a normal application under heavy load. You have the same caching parameters, like all that kind of stuff maps really well to a normal high traffic static website, right? To some extent.
Mm-hmm. Cheaper.
Yeah, and you use all your same contracts and your relationships.
Commodity CDN hardware that's been tuned over the last 20 years to deliver these little packets of data, compared to like these real time, I don't know what you call it, like stateful connections, persistent connections between an end user and a server that has to be kept up. That gets really expensive at scale.
Right, having to maintain a connection to every single viewer. That part alone is expensive. And then like that's kind of like where I've been explaining a lot of the difference here is like, yes, low latency is feasible. You're just also probably going to pay out the butt for it, which, as we mentioned earlier, I think HQ learned pretty quickly.
Just on HQ note, I think we were doing some math early on. So HQ, we were like snooping their traffic when they were early on streaming, and they were doing some stuff that you would expect a startup to do, just kind of using the quickest technology to get them to what they were trying to achieve. And originally, we saw them using Rtmp to stream video like directly to every one of the users. And we did the math on that, and it was, with hundreds of thousands of viewers, Rtmp connections to each, thinking about just the transcoding and the like Flash servers or Wowza servers involved, was probably around like 30,000 a show, without even getting into like the network delivery and things like that. So probably not the most efficient, probably not the most accessible to other people trying to do the same thing.
Mm-hmm. What's interesting is drawing these lines around where these spectrums start and end people has been traditionally very, very woolly from a business perspective, right? There's this commonly thought of number that broadcast television, particularly in America, is somewhere in the region of a 15-second delay. Glass to glass, which obviously varies massively, right? As Steve said, the Super Bowl had a lot of built-in latency, designed around performance reasons. And then there's this very woolly area of how close can you get to kind of that 15-second broadcast latency with the traditional technologies that Matt mentioned, right? The HLSs, the chunk delivery technologies. And then anything lower than that, kind of becomes this super woolly area where we need some new technology that looks a bit like real time, but also looks a bit like these traditional HTTP based technologies before you get down to that true real time conversational component.
Yeah.
I think to us, like low latency would be anything above a second, but below 15 seconds, say. And then there's a scale there of ultra low latency being kind of that first 1 to, 5 seconds, and then low latency being kind of 5 up to that kind of broadcast latency level. Would you agree with that, Steve?
You're saying ultra low sub 4 seconds? Is that what I'm hearing?
Yeah, pretty much 4 to 5, somewhere in that region.
Okay, yeah. And like real time being sub 1 second.
Yeah.
Or really, like real time is really like sub 300 milliseconds, essentially, right?
Yeah, it should be. A lot of people advertise and, claim real time that is about a second. As we're experiencing now, I don't think everyone would agree with that.
No, anything above 300 milliseconds, like if you're trying to have a Zoom call that's above 300 milliseconds, you're pissed off. Like it's not a fun experience.
Right. Even this, where the latency is probably actually like, I'm assuming 700, 800 milliseconds. Like it's not that high, but it's still just high enough where we keep like running into each other trying to start talking because that queue just is just slow enough where it makes it tough,
Mm-hmm. So yeah, that feels like pretty good lines to draw. I mean, we've seen different groups try to, like Wowza, I think was the original post that attempted to like name these things, and Will Law had a good update on that. And then Phil, you created a version of it for your post. I think, it's all hovering around the same seconds, 0 to 1 real time, 1 to 4 or 5 low latency, things above 5 starting to get into more standard latency. And it's this kind of juggle that maps somewhat closely the technology that's driving you to those different levels.
And sometimes one of the challenges is there is this association of low latency being a parallel for like synchronous. Like it doesn't matter necessarily in some use cases if the latency is low, as long as the streams are, for example, well aligned. And so long as, everyone's getting experience at the same time, and so long as metadata is timed, that can be part of an experience, right? For example, you can, if you were building your own HQ trivia, but you didn't want to have that interactivity with the audience as much, then so long as the questions appeared at the right times and that sort of thing, you actually don't care as much about the latency as the fact that all the questions are aligned and the viewers are all aligned as well.
Yeah, that's a really good point, because it takes slightly different technologies to achieve synchronicity than low latency. Like, the lower the latency you get, the more you get synchronicity built in. But like, yeah, they're not necessarily synonymous.
And I think one of the things I always like to highlight when we have a lot of conversations about this with, at work with clients, as well as, on video dev and in, Demuxed circles as well. But one of the challenges and the things that a lot of people who aren't deeply versed in the industry is that there is always a sacrifice of stability with latency, stability and quality in many cases for latency, right? If you want to bring your latency down, you probably want to send smaller packets more frequently. That's going to make you kind of more susceptible to any network conditions that might be going on, whether that's someone putting a router on top of a microwave and turning a microwave on, whether that's someone starting to watch Netflix in the next room. There is always going to be, regardless of any of these technologies, no matter what any vendor tells you, there will always be this challenge of making sure that, sacrificing a stability component for a latency component.
Mm-hmm.
Yeah, that's an important note that I think gets lost in a lot of this, is that trade-off. Like, we can continue to, even as like we reliably start decreasing latency all throughout the chain from end to end, from broadcaster out to delivery, every issue that you can have along the way, which are legion, it's the internet all the way through. Every issue you can have along the way gets magnified when your margin for error is down to milliseconds instead of potentially seconds. Mm-hmm. All of those things that could potentially save you and help along the way, those all just go away. And now you're just kind of generally screwed if the encoder disconnects, or even the viewer's connection gets bad and like their buffer completely is exhausted within 500 milliseconds. Like all those cause problems.
Yep.
Yeah. At the player level, that's essentially what it is, right? Like we're talking about decreasing the buffer in order to get lower and lower, like closer and closer to real time. But by decreasing that buffer, you're introducing the risk of rebuffers and having to like pause to download more video. And rebuffers are like probably the most annoying thing when you're watching a video. So absolutely, that's a good point.
Yeah. Okay, so we have this kind of the bands for what different kinds of latency are, but we have had low latency video in the past. So like let's go through real quick. Like pre-Apple, this latency was possible. We talked about with HQ Trivia, and it's been done. So talking about those technologies real quick. The first one that obviously comes to mind is Rtmp. I remember that was like when I first started helping with Video.js, that was one of the most common issues and questions that I think we saw was people wanted Rtmp support in the Flash fallback.
Oh my gosh. That was rough.
There are still people asking for that, right? It's 2020. There are still people actively adding Flash to things just to reduce latency.
Yeah, with Rtmp, I think you could get to, like on average, I think it was actually around like 5 seconds latency, honestly. But if you tuned it, you could get it down to about 2 seconds. I don't remember a lot of like, Google Hangout style applications. I guess no, yeah, you did have some, but they weren't the greatest latency when it came down to it. Like not quite as good as like WebRTC today, but like you could get it down there.
Well, but the huge difference there, if I recall correctly, wasn't even necessarily that the latency was hyper low, but that the playback was all synced. Right?
Yeah, that makes sense because you have like a Flash media server in the center that was like transcoding the stream, and then basically the same type concept of like a persistent connection out to each one of the users. And at the time, CDNs were stocking up on Flash media servers, basically like scaling those out in the same way that they were scaling just your normal HTTP traffic servers, and super expensive, but yeah, that's how they were making this kind of large live streaming, and even like on-demand streaming. A lot of even YouTube, I think, was using Rtmp to stream on-demand video, just because you could get a little bit more consistent, sometimes a more adaptive experience using that protocol.
Well, Steve Jobs went on stage and killed Flash was the big one. So yeah, once Flash died, Rtmp died on the vine in terms of like playback, because if you can't play back in the browser, go home, honestly. I mean, Rtmp is still like incredibly prevalent because it's the most common way that anybody broadcasts video. I've talked a lot about this with like how to go live from the browser, because really you can't unless you go through an intermediary service and then go to an Rtmp endpoint, because that's what Twitch wants, YouTube, Facebook, Mux. I think Wowza has alternative ingest protocols, but the most common one is Rtmp. So anyway, like if you want to broadcast live, you are almost certainly doing it with Rtmp right now. The flip side of that is, I think, why we're seeing so many requests for WebRTC now, just because like that's a word that web developers know when it comes to video. This is where we get to this really interesting split and understanding between these things, where like if you're a developer that's primarily focused in the web, you work a lot in the browser, you know that you can build these chat applications using WebRTC, and you know that a service like Mux or YouTube Live or whatever else does video. So you're like, it follows that like, why can't I just like use this to get to that? So I guess I'd love to hear a little bit just about your all's thoughts on like WebRTC and the history here and how it fits into this story.
That is like, from a technology perspective, it does get kind of like frustrating to hear the confusion behind it, but it makes perfect sense, right? Like video is video to most people, but WebRTC was made to serve like a very different use case than like streaming video to many people, right? And it's meant for like a direct connection to the, like between the people who are communicating. And it does things like basically like aggressively throw out quality in order to stay close to real time. And it says like if your connection starts falling back, like it'll start scaling back the quality of the video in order to stay close to the live edge. Compare that to the Rtmp, which will like, it might get a little bit delayed, but it'll continue to send like the high quality stream to the server. And so that, that's a little bit of a difference between the two. And you can kind of see where at least where they start to differ.
Right. It might help here to talk a little bit about like, I wrote this demo pushing WebSockets to a server that then takes those and pipes those into FFmpeg and then goes out. And so I've gotten a lot of questions from people being like, why not just do that? If it works, why not just have that be the protocol? And the reason I think that WebRTC could ultimately be a pretty interesting ingest protocol, just in general, like it A, is supported from the browser, B, it has things like rate control. So that WebSocket thing, if your internet connection started crapping out and you just couldn't push the blobs of video down this WebSocket connection fast enough, you'd fall behind. Your encoder would eventually choke because it wasn't getting data unless you did additional stuff behind the scenes. You would get disconnected. It just wouldn't handle the bad scenarios very well. Like the unhappy paths look really ugly with that, as opposed to things like the Rtmp specs, WebRTC. Like, I don't know Rtmp as much as WebRTC, but like WebRTC is designed to keep sending video however it possibly can. So you might look like you're being recorded on a potato at times, but you will continue to send video, which oftentimes is preferable over just like the video crapping out and just stopping, right?
Yeah. Well, I think what the difference is here is, and certainly from a broadcast perspective, right? The expectations are super different, which is one of the things that comes up a lot. Like if you, for example, picking up a product that exists on the market, right? If you're using something like LiveView to broadcast like a bonded LTE signal over a bunch of cell networks back to like an edit suite somewhere, like the lower bounds on what is considered like an acceptable video signal there are like still really high in comparison to what like WebRTC considers the lower bounds, right? WebRTC will go to a postage stamp, whereas generally if you're in a broadcast environment, you would say, well, we can't risk broadcasting a postage stamp. So, you know, if you go anywhere below a megabit or something, we're actually going to bail out on this thing. So like, I think the interesting thing there is as the internet is a bit of a different world there to what people traditionally have thought of for a broadcast background for the minimum bounds there. And yeah, like it makes complete sense when you're talking about WebRTC from a, you know, conversational perspective, whereas I think WebRTC from a like an ingest protocol feels like a bit of a different beast in my mind.
I feel like I rarely see WebRTC being sent in higher than 540p video.
Mm-hmm.
I'm trying to remember where I got that from, but like, yeah, I don't see anybody stream 1080p out of WebRTC. Like, it's all about just keeping that connection and enough quality so you know what's going on and it looks decent, but we're not talking high quality.
I think one of the things I'd love to highlight there is there are actually some solutions on the market for kind of low latency and ultra low latency that do use technologies like WebRTC. And the super interesting thing there is there are some that utilize that kind of in the, you know, traditional video domain, but there's also a variety of approaches that just use WebRTC data channels to shuttle video around, which is kind of super interesting for a variety of reasons, because that's for example a way to keep that sustained connection there, but not necessarily be, you know, have that rate control that's built into WebRTC's video channels, which is kind of a super interesting approach on its own. And there are a variety of people doing that sort of thing as well.
Mm-hmm.
Do we want to dig into low latency dash for just a second?
Mm-hmm.
Since that's probably the thing that's most analogous to the low latency HLS spec that kind of kicked off this conversation.
Yeah, sure. So, I mean, this is one of those super interesting cases where, you know, we're kind of now all talking about this really in my mind because, you know, would we be doing the podcast if, you know, Apple hadn't really thrown some fuel on the fire here? But, you know, low latency MPEG Dash has been around for, you know, a few years now and is relatively well understood and works relatively well. And this is one of the fundamental components to how people think about low latency streaming on the internet today. And it's also what presents the challenges and also what, you know, ultimately Apple set out to address in their specification, right? Which is that the low latency dash spec uses something called chunk transfer mode, right? So this is a mode of HTTP. So it allows you to make a HTTP request, but send a response that doesn't have a content length header. So you can start sending your response before you know what you're sending. And so you can send, you know, a chunk of a transport stream segment or a CMAF chunk as it would be in modern day parlance. So you have these HTTP requests that get made, and then it's kind of going to take, say you've got a 2-second segment of video, it's going to take 2 seconds for that to be downloaded because you're kind of streaming these chunks out the encoder and packaging layers as they come. And this is kind of not chunk transfer mode has been around for a very long time. And in fact, it predates HTTP 1.1, in fact. And this is how the low latency dash spec is designed to work. And it works actually really well. And it works really well on actually even relatively lossy networks and high latency networks. It works well. The place where this technology has been fundamentally challenged over the last, year and a half has been the fact that this is a technology that is really hard to get to work right with changeable networks. If you have a network that's got like a 1 second latency in it, HTTP request latency in it, this technology will actually work fine with that. If you're on a network where you've got some packet loss, this technology will generally work fine with that as well, because, as long as it's a consistent amount. The challenge becomes when you're talking about a network that is fluctuating, where the bandwidth or the packet loss or the latency on that network is fluctuating, because if you think about traditionally how we measure bandwidth in a HTTP environment, right? You do a request, you look at how long that request took to happen, and then you say, cool, speed equals distance over time, right? And you can look at how big that file was, how long it took to transfer, and then you've got a good estimate of the network capability of that device. And you can do that on every segment in a more traditional HTTP world, right? Say you've got or Dash world, right? If you've got a 2-second segment, you get to do a bandwidth measurement every 2 seconds, which allows you to react quickly. But in a world where you're downloading these parts every, 2 seconds, but they're taking 2 seconds to download, you don't really have an opportunity to do bandwidth measurement there. And this is where this technology has become fundamentally challenged over the last 18 months.
Mm-hmm. Yeah, so adaptive streaming has proven to be difficult, right, because of measuring the actual segments that are coming down. That's interesting.
And these aren't new technologies, right? So if you look at how LL works, it's really these concepts were all coming out around the same time. So I'm not going to say directly who, I think really there were 3 people in the industry all effectively doing the same thing at the same time. And, it was the low latency dash group, which is, Stockhammer, Will Law, those sorts of people. There was also Periscope at the time. This is a pre-Twitter acquisition. They also took the exact same approach in their low latency streaming product. It was HTTP chunk transfer mode, but also Twitch, right? Twitch, even still to this day, right, still continue to use a version of, chunked transferred HLS. It's not Dash, but it is, built around this fundamental approach of using chunk transfer on HTTP-based streaming technologies.
Now, there have been attempts to improve the adaptivity of that, right? Like to actually build an algorithm that can measure the chunk transfer encoding?
Yeah, absolutely. I mean, there's been a variety of ways that people have tried doing this. The most primitive way, which some people still use, is to, every 10 segments, go off and get a segment at a line speed and use that as your measurement. Now, like I say, that is what gives you challenges in rapidly changing network environments. And in fact, you can still see this happening on, products like Twitch even. Twitch still falls back to a higher latency experience if your connection is fluctuant. There's been other approaches. For example, one of the common approaches is based on buffer fill rate. So is your buffer filling or is your buffer draining? And that can give you a good indication of whether you're getting frames and stuff in quickly enough. And there was a really good white paper as well on this. Came out of ACTE last year. It's just a really good novel approach to this as well. And in fact, there's I believe it's still on. I'd have to check, but I believe Twitch are actually offering a pretty big reward in this year's ACTE to someone who can produce a bandwidth estimation strategy for low latency that outperforms current approaches.
Yeah, before we get into Apple's official low latency HLS spec that I think is kind of the catalyst for a lot of this, there actually was a really good community spec that was released. Mm-hmm. It had a lot of folks interested in it. Quite a few companies were actually starting to develop against it. It was developed by John Bartos, who is the maintainer of HLS.js. So he announced it at Demuxed 2018.
18. Yeah, I want to say 18.
And it really did. It had legs. People were talking about it, developing against it. We had started working against it because it didn't seem like the kind of thing that Apple, correct me if I'm wrong, at least in my opinion, it didn't feel like this was going to be the type of thing that Apple was going to explicitly do. So I was kind of shocked when Apple did. And we wrote the whole blog post where, honestly, we were a little bit annoyed that Apple kind of quietly behind the scenes went and did this thing and didn't really involve the community. And we had this kind of community-driven thing.
Well, it was that plus just the fact that it was so different from everything that the community was doing.
Right.
And this is the thing, right? The community approach was going to be fundamentally interchangeable with LL Dash. Will Law was working closely with John on that, which I think made a big impact on how people viewed that in the industry.
Yeah. Anyway, shout out to Bartos there. That was he put in a ton of work, and it was really impressive, and we were really excited about it. And the demos he showed a demo at Reframe in New York.
Reframe.
Shout out to Reframe.
Yeah, shout out Reframe. He did a demo there that was really impressive, and like the way that it, you could have like pinned latency. It was, I don't know. I was really excited about it. So it was a shame to kind of feel low latency HLS jump from being something that could have been available in, I don't know, end of 2019 for a lot of people to just like completely stopping all momentum there.
Yep.
And suddenly like low latency HLS was relegated to being kind of when we would start seeing more, like nobody was going to keep working on something when Apple was going to release an official thing in the next year, 2 years. Mm-hmm. So like everything just went on pause, and it went from being something that was really tangible and like right there to being, a year plus out, which we're still waiting.
Mm-hmm.
I think what's really important to highlight there, though, Matt, is while it was there and within touching distance, right, it didn't give an answer for iOS.
Yes.
Right, which is always going to be kind of one of the biggest challenges here is like, yeah, we can say, hey, this is here and it works with like the Bartos spec and the LL Dash spec, right? But if it doesn't work on an iPhone, does any of that matter, right? Or kind of more specifically, if I have to ship, a completely custom app with a bunch of proprietary stuff in it, is that going to make it for Apple's, approval process? And, even if it does, is that how you want to go about building and maintaining your app on iOS? And I think the reason that part of a reason, at least, that Apple get to kind of win on this by bringing in their own spec is the fact that they can say, oh yeah, and by the way, it'll actually work on an iPhone at some point down the road. Of course, nobody still knows when that's going to be, even for what we're doing now. We still don't know when Apple are going to release official support for what they're proposing now, but one has to imagine it'll be at some point, right?
Well, and then the other side of it is we don't know how well it's going to work in the browser. Whereas like the community spec, was built for the browser. The Apple spec really is pretty untested in the browser and relies on things like H2 push, which is pretty raw from browser support standpoint, especially for transferring video files, not just CSS files. So that's kind of open-ended.
Yeah, but hey, the good news is it's no longer HTTP2 push. Mm-hmm. It's not much better, but it is marginally better.
Mm-hmm. Which is a nice segue into Apple's new low latency HLS approach, right? Because they essentially bypassed that whole issue with the way that they approached it. Is that right?
Yeah. Now, I think this is an interesting one because there's a little bit of background here that we should touch on, right? About a year ago, it was WWDC last year when Apple formally announced, "Hey, we're putting a low latency mode into HLS." Roger Pantos, gets his session at WWDC and gets to talk about stuff. And this year is how we're going to do low latency. And I think what's interesting here is the business cases for what they were pitching were pretty much aligned across all of the approaches, right? They were pitching something that gave around 5 seconds of latency was their number. Utilized traditional HTTP technologies, wasn't changing the world per se. It changed the world in a different way, but that was their initial pitch. Is it's still trying to solve the same business case that LL Dash and the community low latency HLS, which we haven't really talked about, spec were designed to solve as well. It's still that sort of territory of latency tuning. Now, of course, what's interesting there is that kind of kickoff process from WWDC when that was announced really kicked off a lot of conversation in the video developer space around the new specifications. So The new specification introduced a variety of new features into HLS that we'll go into in a bit more detail on the next episode. But the big change really there for Apple was they wanted to move a low latency into a world of a HTTP2 push delivery technology rather than kind of the more traditional HTTP gets that you see being executed for traditional HLS and traditional DAS. And they very specifically avoided going down the route of the chunk transfer mode that was common to both LL Dash and the community approach for low latency HLS as well. Now, a lot's changed over the last 12 months. We're coming up to 12 months from the last WWDC now. And that spec's changed a lot and has evolved and now looks quite different to what it did. And, huge thanks to the guys at Apple, but also everyone else in the ecosystem. A lot of the video industry spent 2 full days giving feedback to Apple, working with Apple to resolve issues on the low latency HTTP live streaming specification. And, we believe a lot of those are now resolved in the latest version of the specification. And one of the critical things to the people in the room there, and, to give some idea, this was 35, 40 people from around the video streaming industry. And what was common with all those people is really what everyone wanted was an interchangeable specification here. They wanted to make sure that they could reuse, in particular, the media chunks that were coming out of their encoder and making sure they could be fed in a universal way, ideally through one CDN configuration that worked for, the vast majority of devices, right? If you imagine LL Dash working well for, Exoplayer on an Android device and potentially a web client, everyone's desire was to use those same encoded segments ideally served in the same way over a HLS-based technology. We'll get into that more next episode, right?
Yeah. Mm-hmm. Hopefully, if you weren't familiar with kind of the landscape of what was going on with low latency HLS and the Apple ecosystem and what all this means, hopefully that's a little bit of an overview. The plan for this next episode is and when I say we, I mean mostly Phil, will dig into the new HLS spec and really explain to us what that means, what the changes are that were recently released, because Pantos actually they announced all of this, but last week or 2 weeks ago was the first time we saw like an official release of the HLS spec.
Yep.
So we'll learn what's in there, what we've actually seen, what the changes are. And I think that's where we'll take the next episode.
That's all we have for today. But as always, we'd love to hear what you thought, even if you disagree. So please reach out on Twitter at Demuxed.
To learn more about Heavybit, visit heavybit.com. And while you're there, be sure to check out their library. It's packed with amazing talks on sales, marketing, product, and general management from founders of developer tools companies and other industry leaders.